Hello guys, here we are going to explain our project, which is smart metering using IoT. IoT stands for Internet of Things. Here we are going to use Ethernet Shield and Arduino and a simple circuit using current sensors and relays. This is our Arduino code. It will be uploaded after, and this is our modem. We use Ethernet cables, and the modem is connected to the PC, and from the modem to the Ethernet shield. These are our loads: a fan, DC fan, and a DC motor. This is the relay, and this is the current sensor, ACS 712. This is our circuit. We are using filters and some circuits in order to reduce the noise and in order to not damage our Arduino. This is filter capacitor across the plus minus of the Arduino. We have measured the voltage across the expected 5 volts. We found it 4.817 volt, and this is very good information. And now we can start the experiment. Right, the first step is to connect the Ethernet cable to the Ethernet shield. We can see here these lights are turning on. This indicates that the Ethernet shield is on, and it is connected to this modem right here. The code will give us the IP address of this Arduino. We open the serial monitor. This is the serial monitor, and in just seconds, alright, it gave us the IP address. The IP address of the Arduino Ethernet is 192.168.1.7. We shall memorize this IP address and use it in the next step. And now, since we have the IP address, we will start by testing it with this logiciel here and this program, which is Heracles setup. We use TCP client. From TCP client we gave the model IP, which is here. We can replace it by 7.7, and the port is known as 80, and we press here connect. See, connecting and connected. This indicates that we have successfully connected to the Arduino Ethernet shield. In order to test the circuit, we read the algorithm and the protocol. The protocol here says if there is a small a, the Arduino will send the analog read of a 0, and in case there is a capital A, the Arduino will switch the load 1 to high, and in case of small b, the Arduino will switch the load 1 to low. Let's try this in Heracles. Alright, we have here the cases: A, capital A, small b. We shall send these messages to the Arduino right now. Right here I connected the circuit, and now I will switch the power supply on. The power supply is on, and now we will switch the load on by this capital A, as the protocol says. Right, now we will expect this relay to turn on. Here we are. This relay turned on, and this motor here started to spin. Now, following the same protocol, we can send small a to reach the reading from the sensor, the readings that tell us the current. Okay, we can send a. See here. See, these are the readings. Okay, if I keep pushing, it keeps giving me the. Okay. Now I will put my hand around the motor, and in the same time we will going to send small a to see what the reading gives us. Okay, just a minute. So now as you can see, the LabView program is up and running, and we can know when it is running by switching this relay on, and we can know it is running because the connection will take time. So this is the relay number 2. We switch it on, and now we will wait. Right now, as you can see, the LabView program now is up and running. You can see right here, this is the current, and this is the rated voltage. It is now underrated. You can now turn it off, and also turn this off, like this. You can see now the current is this is the load 1. The rated voltage of the load 1 is 5 volts. We make it 5 volts, and the rated voltage here is 12. We make it 12 volts. Now we turn on the relay number 1. You can see now the current is up, and the power also. Here also, we turn it on. Relay number 2, you can see the current here, and the power here. Thank you. Now I will make some disturbance for the motor. See, the disturbance raise the current above to 1 amp. Okay, you can see now I disturb it. If I disturb it, the current goes up. This is it. And this is the fan here. It consumes so much energy, as you can see, because the rated voltage is 12. You can see. These 2 pulses are the pulses of my disturbance. Okay, this is and this alright. We have also the total power here. You can see here the curve of the total power. This is up to here, up to 20, and now it is somehow stable. The total power is somehow stable because of the temporary stability here. This temporary stability, it's temporarily stable, as you can see here. And now by turning off everything, you can see the current goes down to 0, or approximately 0. You can see here the current is approximately stable at 0, as you can see here. This is the final curve, and this is the bill, or the total energy, as you can see here. This is it. This is the curve of our usage of the power sources, and this is our project. We hope that you consider it right.